Okay, today is March 26, 2015, and I have Shania here for our session, and we're going to just go ahead and get started. Now, say, um, I'm gonna try to just do this like this to go over what we're doing. Okay, so we're gonna do the before you read, and let's go ahead and just read this first part before.
In this section, you will learn about Charles Darwin and his theory of nature section. Read the first paragraph of Read to Learn section on the line below. Write the ideas and life on Earth that were common during Charles Darwin's time.
Okay, so that's something that I want you to do. So I want you to read this first paragraph right here. So it says developing natural selections, and I circled that because that's one of the main content areas of this. So that's one of our main objectives. We're going to be learning about Charles Darwin. The main idea is Charles Darwin developed a theory of evolution based on natural selection. So I want you to go ahead and read this one and then take about 2 to 3 minutes and then write your sentences on that line. Okay?
When Charles Darwin boarded the HMS
Boarded.
boarded HMS Beagle, people believed that the world was only a few thousand years old. Most people believed that plants and animals they saw had not changed. Darwin believed these two things too.
Okay, so I want you to stop there. We're not going to keep going. Then we're going to come back up here and read this question. It says on the lines below, write the ideas about life on Earth that were common to Charles Darwin's lifetime. So Charles Darwin lived years ago. So if you could just think of maybe one or two things that are perhaps common throughout life that we know about history, what's like one thing that comes to mind?
Animals and plants.
Okay, so go ahead and write that. All right. So we're going to go through each one of these reading checks too. So as we go through, we'll be answering the questions and seeing where we are. So this one asks us to identify the main ideas in each one, and we're going to do that here too. So we're going to start with what did Darwin do on his HMS Beagle?
This mission of Beagle was to serve the cause of South Africa.
And I'm well, each time I underline a word, I'm gonna just underline it, but I'm gonna say survey.
Survey the cause of South Africa. America.
Mm-hmm.
Darwin's original role on the ship was the captain companion.
Good job.
He was someone that the captain could talk to during the long voyage. Darwin also served as a ship naturalist. His job to collect rocks, fossils, plants, and animals from the place he visited. During the 5 years war, Darwin read the principles of geology by Charles Lyell. Lyell book Protest the Earth was million of years ago. The book influenced Darwin's thinking as he found fossils and marine life high in the Andes mountain. He also found fossils of great version of smaller living mammals. He observed how earthquakes could quickly lift rocks great distance.
Mm-hmm. So I'm gonna go here. This is giant, and this was proposed. But we're gonna do this reading check right here. So this says, name an observation Charles Darwin made. So what is one thing that Charles Darwin was able to observe in this?
How earthquakes quickly lift rocks.
Okay, so you can write. This is actually where did you get very far in class with your notes today?
Mm-hmm.
You did? Okay, so were you understanding a lot of it or just kind of gibberish? Okay. Because all of this is kind of reinforcing that. But the reason why I do evolution this way is because it's more so application. So when we come to school on Monday, it'll be lots of examples, hands-on. I'll put us in groups and we'll be able to mimic, the geographical isolation. We'll be able to mimic the pre-zygotic isolations and things like that, and this actual natural selection theory. But, okay, so we're gonna keep going. All right, so we're gonna talk about the Galapagos Islands, and anytime you get to a word that just doesn't seem familiar, you can just stop and we'll just say it together.
One of the places that the Virgo cell was the global
Galapagos. Yes, I even have some trouble stumbling over that word.
islands off coast of Ecuador.
Mhm.
Darwin noticed that the mockingbirds on the land were slightly different from mockingbirds on other land. He took careful collections of these birds. Darwin thought that the finches he saw was not related
Mhm.
to one another proper. He had recessive
Representatives.
representatives on mainland South America, although he noticed the differences, he did not think such about these differences at time. Darwin also did not notice that tortoise shells were different on each island. When Darwin returned home, he showed his
Specimens. You're close.
to naturalism. John Gould
Mhm.
told Darwin that the mockingbirds from different islands were different species. Gould also determined that the
The Galapagos.
Gal-
I know it's a tongue twister almost.
Galapagos
Yep.
French did not live anywhere else in South America. They were different species too. A few of Darwin finch are shown in the pictures below. Notice that different in back, size, and shape. The Galapagos finch most closely
Resemble.
resemble finch from the coast mainland in South America. Darwin suspect that populations from the mainland change after reaching the Galapagos.
Mhm. Okay, so these were the finches they're talking about. So the first question asks us to identify where are the Galapagos Islands. So where are the Galapagos Islands? It would be in that first couple of sentences.
Coast of Ecuador.
Yep. Okay, so the next one asks us to picture this. Explain each of the Galapagos Islands had different types of plants. How might this explain the differences in beak shapes in finches? So, my first question is, do you understand what they were asking? Okay, so they're asking you to compare our plants and our finches. So, what is one thing that you say that might explain the differences?
Some have short beaks and pointy beaks.
But
Finches.
finches. But how do you think that has? What do you think that has to do with the different plants that are on the different islands.
Oh, different plants.
Well, what they're saying is that you have different plants that are on one island, and you also have different animals, which are the finches, that are on different islands. So, what do you think? How is that related, or do you think it's related at all?
I think it's related because different birds eat different plants.
Yes, that's exactly the reason. That is exactly the reason. So they eat different things. As you can see, this one got one small thing in his mouth. This one has like a long branch in his mouth. So based on their location, they're gonna eat different. They're gonna seek different things. So they're gonna need a different size beak to help them with what they're doing. So you can shorten that and go ahead and answer that question. That's fine. I'm gonna check out this beginning. Okay, so now look at this. We almost through section one, I believe. Okay, so now this next part is going to be talking about the actual principles. We're going to start getting into specifics of what really shaped and really paved the way on how we view the world and how we got here, how animals got here. So we're going to talk about the principles that Darwin did use. So I'll let you go ahead and start that section.
Darwin developed a theory for how one species could change to become multiple new species. Darwin based his theory for four principles. Principle number one involves in a population individuals in a population shows difference even among the same species. Differences among you and your classmates support the principle. Principle number two the difference between the individuals are in, inter, inherited traits are passed down from parents to the offspring. Principle number three animals have more younger than can survive on the resource in their environment. For example, the average female cardinal lays 9 eggs in the summer. For each of the offspring living 1 year, the reproduction in 8 years, the offspring would produce 1,000,000 cardinals. The population of cardinals would quickly outgrow the food supplies. Principle number four. Some difference increase a organism reproductive success of the change of having living offsprings. Any difference that increase reproductive success will be inherited by offsprings and will be more common in the next generation. For each pigeon with a fan-shaped tail have more reproductive success than pigeons without fan-sized tails, such as results more pigeons in the next generation will have fan-shaped tails. These principles form the base of Darwin's theory of evolution by natural selections, which exemplifies how traits of evolution can change over time. Darwin reasons that given enough time, natural resources such could produce a new species.
Good. Okay, so gonna stop before we move on, and then we're gonna answer this, think it over. So it says identify, name a resource that can limit the survival of animals within a population. So which one of these principles do you think even applies to that?
Principle number 3.
Okay, so principle number 3 is talking about offspring. So if we go back to the question, it says identify, name a resource that can limit the survival of animals within a population. So what is one resource that can limit the survival?
More food supplies.
Absolutely. Food supply is definitely a resource that's going to limit it. So go ahead and answer that question. Awesome. Excuse me. And also put food supply under there. Awesome. Okay, so this next one says to think it over. Well, first we need to go back here, excuse me, the origin of the species, so you can go ahead and start.
Darwin began writing a book describe how natural selection could produce new species. In 1858, he learned that Alfred Wallace, another English naturalist, had reached similar conclusions about natural selection. In 1858, both Wallace and Darwin presented their findings at a scientific meeting. In 1959, Darwin published his book on the origins of species by meaning a natural. Darwin did not use the word evolution until the last page of his book. Today, biologists use evolution to describe the way species change over time. Darwin's theory of natural selection explains how evolution can occur.
Okay, so now we're going to go back over to this think it over. And it says contrast. How does natural selection differ from evolution? So they have evolution underlined here, and then we would have to go back and read what your natural selection was. And I think they talked about it up here. So what would be some of the differences between natural selection and these 4 principles, and then the definition they have here, and then the definition they have here?
Oh, well, natural selection could produce a new species,
Okay.
and evolution describes the change over time
Okay,
of
yes. So
species.
the main difference is natural selection has the ability to make a new species. So you can make something new. Evolution is just like you going from a toddler, and now you're a teenager, and then 10 years from now you're going to be a young adult, you're going to be in college. That's evolution. So go ahead and put that into your own words and then explain it for number 5. It's okay if you write off the page because it's still yours. Okay. So now that we have finished section 1, what would you say is the main idea of section 1? And I'll let you go back and look at it before we move on.
The main idea?
Yep, if you had to sum it up in one sentence.
The main idea was basically about species back then and how they change over time.
Okay. I would definitely say that. So we talked about different species and how they change over time and the actual theory of natural selection. So now when we go on to evolution, we're going to talk about some different evidences of evolution. So let's do this before you read, and I'll let you read that.
To learn how different organisms might
Mm-hmm.
to be related
Oh, it's still going.
be related to scientists. Look for similarities and difference between the organism. On the line below, compare a cat and a frog. Which physical features are the same? Which big physical features are different?
Awesome. Okay, so what's the first thing that comes to your mind when you think about a cat?
Cat is a mammal.
Okay, yes, that
and
is.
The frog is a reptile.
Yes, go ahead and write that. That is one of the most important and I think vital details of them all. So yes, one is a mammal and one is a reptile. They're in two totally different classes. What would you say about their structure, how they're made, like physical features?
One is slimy and one is not.
Okay, so yeah, you could say one is hairy and one is slimy or wet, per se, maybe. Okay, so that was perfect. So now we're gonna go down here. We're gonna still do the main ideas and things. We're not necessarily gonna do this foldable, but we're still gonna answer these questions. So I'm gonna have you do the support for evolution. So you can go ahead and start.
Scientists use theories that provide explanations for how some
Aspects.
aspects of the nature world authorate
Operate.
operate. Any theory should explain
Mhm.
ability
Available.
data to suggest further areas from experiments. Darwin's theory of ele- 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 evolution by natural sections explains the patterns scientists see in past, the present organism. In most cases, people cannot observe. Ele-
It's okay. Evolution.
ele- ele- oh my God.
Evolution. No, it's okay.
Direct because it happens over millions of years. Fossils help use understanding evolution because they are recording of species that lived long ago. The fossil record shows that some species from long ago extinct today. Other species live today are similar to those in fossils.
Okay, so here it is access. Here it will just ask us to make a four-door foldable as shown below. As you read and take notes and organize what you learn about Charles Darwin and the development of the theory of natural selection. So here we're just talking about Charles Darwin and what we're doing. So we're going to continue on and we're going to see what did Darwin predict about the fossil record.
Darwin predicted the scientists would find fossils that would show organisms that were intermediate between different species. Darwin's predictions had came true. Scientists have found intermediate species from the evolution
Yes.
of
Mollusk.
modern horses well and human.
That is true. Do you know what mollusks are? Mollusks are like those little clams, or I don't know if you ever ate mussels. Mussels, they're not they're not my favorite, but they're kind of like a clam, but it's not as raw, it's not as slimy. It has like real meat inside. But all of those would be considered mollusks. And then you have your horses, whales, and humans, which we all know are mammals. Okay, so we can move on.
What are two classes of traits? Scientists have found fossils of
Archaeopteryx.
Archaeopteryx, a dinosaur that had teeth, claws, and a bony tail. The reptile and feathers
Feathers.
and the ability to fly like a bird. Archaeopteryx is like an intermediate
Intermediate.
and it's evidence that birds evoluted
Close. Evolved.
evolved
That was
from
really close, though.
dinosaurs. Scientists divide traits into two classes. Derived traits
Derived.
traits are newly evolved traits that have not appeared in common interact
Ancestors.
ancestors. Intertraits,
Ancestral.
ancestral traits are traits that are shaped by the species with a common
Ancestor.
ancestors. In artifact,
It's Archaeopteryx, but that one's okay because it's just a really uncommon dinosaur.
teeth are an example of
Ancestral.
traits. What does the entomology revolve about evolution?
Yes, this one is anatomy. What is the anatomy? An anatomy is just like your body, your bones, your hair, your skin reveal about evolution. Okay, keep going.
The limbs
The limbs.
the limbs of vertebrates perform different functions, but they have similar anatomy.
Anatomy.
Anatomy. Wings and legs have similar structure because birds and animals evolved from the same ancestor.
Homologous. You remember that word from our last genetic unit? Remember the homologous chromosomes? Now we're talking about homologous structures.
Homology structures are similar structures
Inherited.
inherited from the common ancestor. Darwin's theory of evolution by nature section predicts that new structures are more likely to be modified of ancestor structure than
Entirely.
new feature. Figure below shows a
Homologous.
forelimbs
Forelimbs.
of three animals.
Good. Okay, so here it says these are different, what we would say, homologous limbs. So this, of course, would be the typical human, or close to human. That's a kind of long finger. But it says identify on the blank lines of figure. Write the function of the forelimbs for each animal. So what animal do you think this is?
A dinosaur?
It could be a dinosaur, or maybe even a cat or a dog, because that looks like almost like one of those legs. And then we're gonna say this is a human, and then what would you say this is?
No, that's a dinosaur.
Or like something that or maybe it's like a pterodactyl dinosaur. It could be one of those because they fly now. It's asking us to identify what do they use each one of these for. So what do you think this dinosaur or cat or dog is using that for?
To walk.
Okay, to walk. You can write that. One word. Okay, and then what about the next one? What do you think they're using their forelimbs for?
To like pick up stuff.
So yeah, you can write that. Pick up stuff. Okay, and then that last one, what do you think they're using that for?
To fly.
Yes, absolutely. So the point of this is we want you to see that it is all different animals, all different functions, but they're very closely aligned. If you look at down here where they have those carpals, these little parts of your fingers are known as like carpals. These, they have carpals. The little cat dog dinosaur, they have carpals, and then each one of these little sections on here are meant to mimic what these are in our fingers, the carpals. But we'll learn a little bit more about that. But let's talk about the vestigial structures.
Vestigial structure. In some cases, functional structure in one piece is smaller or doesn't function. In a close related species, vestigial structures are features that are reproduced form of functionality structure. In the other organism, vestigial structure are reproduced when structure has no longer reduced. No longer structure needed. The structure becomes smaller over time and might even disappear.
Okay, and that was really good. This one's eventually though, so it said it might even eventually disappear after a while. So if you had to define what are vestigial structures, what would be something that's an example of a vestigial structure?
A feature of reproduced forms.
Okay, so if we had to give like an example of like what do you think that would look like in a person?
Like their hands.
Yeah, but let's go back and read it. Says vestigial structures are features that are reduced forms of functioning structures in other organisms. So even if our hands may be in one thing and something else, it may be a wing, or it may cause them to fly, or like even in the finches, their hands were their little feet. So that could be a comparison. So I'll let you go ahead and explain that in your own words. Alrighty. I guess we're almost. Let's do a time check. Okay, so how are you getting home today?
My mom. And that's my sister, then was just calling.
Really? Okay, well, we can be done for today. So we're gonna stop right here, and then we'll probably pick up right here next Thursday if you're available. And next Thursday probably will be our last Thursday because we're going on spring break, and then we'll just kind of cram. And do you think you're gonna be able to make mine? I don't know if I'm gonna do Friday or Saturday, but I'm gonna start doing some intense, like just cram sessions for the EOCT. And I think it would really benefit you if you can come. Just if you can come. So do you think you'll be available at least one Saturday out of April? Okay.
She's gonna make me come probably all Saturdays.
Okay, well, that's
Cause she want me to pass.
Yes, I want you to pass too. So that is our plan. So I'm going to pause this right here. This concludes our section. We stopped on page 174. And this will be a part of